Okay, so let's look at page 90, number 18. Page 90, number 18 says, drawing a triangle DEF, okay, and these are the coordinates of DE and F, and you're to draw the altitude from vertex D. So, to draw an altitude, first we need coordinates, and here is our DE and F, and you're to draw the altitude from D. Alright, to do that, folks, we need to do something really kind of strangely unique to some of you. But literally, I'm going to take this, and if you had a piece of paper in front of you, you would have taken this particular triangle and moved your page. So I'm going to actually physically move the page, as you can see the grid, so that my D, E, and F, my actual E and F, lies on a horizontal. So I'm going to draw it right there. So that's let's draw it horizontally, and so that E is exactly at the bottom line. All right, now that we did this, what we can see is now you're asked to draw the actual altitude from vertex D. So now that you see this, but I can tell you right now, this little point right here is not exactly at a right angle to this line. It's actually just slightly off. Okay, so what happens with this one exactly, folks, is that the altitude from D means that this line is actually going to be just to the right of this, just slightly. Okay, so just slightly to the right of it, and so that when you draw the actual perpendicular, it actually goes up slightly like that. All right, and what you're to do is find the equation of the altitude from vertex D. How do you find the equation of an altitude? Well, you find the slope of this side, and then when you find the slope of this side, you take the negative reciprocal. That will give you the slope of the red line. And once you find the slope of the red line, you can use vertex D to actually find the equation of the altitudes. Use the vertex D and the negative reciprocal slope of this EF to find the equation of the altitude. That would be the red line. So again, it's slightly off, and that's why in the back of the book it looked like it was a right angle triangle, but it really isn't. So you're to find an equation from vertex D, and that could be one of the questions. Now we're going to go on to a couple of questions from 2.5. Okay, we're going to focus on page 98, number 17. A ship drops its anchor into the water and creates a circular ripple. The radius of this ripple increases at a rate of 50 centimeters per second. And what that means is now we're going to look, this is how much the ripple increases at the circle. And you're asked to find an equation for the circle 10 seconds after the anchor is dropped. So if you imagine that the anchor is dropped at the origin, okay, so that means that our circle will have x squared plus y squared equals r squared. So we need to know what the ripple, how big the radius of the circle is. So this is the radius growing at 50 centimeters per second, and we need to be able to find the equation. So the equation is the radius, which is 50, times 10, because it takes 10 seconds, and all squared. So you're going to have x squared plus y squared equals 50 times 10 all squared is going to equal 500, no, sorry, that's not correct. It will equal 25 and 4 zeros. So 250,000. X squared plus y squared is equal to 250,000. Now, part B says a small rowboat is 50 meters east and 75 meters north. So, if we were to actually draw this out, 50 meters east, now remember that's meters, and we're talking about a ripple that's centimeters, so 50 meters east and 75 meters north means it's 50, 75, or in meters, okay? Or if we're talking about centimeters, it's going to be 5,000 and 7,500. And again, this is measured in centimeters if you're to convert it. Now, this is from where the anchor was dropped. How long does the ripple take to reach the rowboat? So, what you need to do is find out how long does it take for this ripple to reach this boat over here. So we need to find the distance of this line. Once we find the distance of that line, now remember, if we use the centimeters, which is what I highly recommend, you'll get your answer in centimeters. And once you get that, you can divide it by 50 to find out how many seconds it will take. And guys, it will take about 180 seconds, which is about 3 minutes long. Now again, you have to assume there's some assumptions made, and logically the assumptions would be there's nothing in between the rowboat and the ripple, and there's nothing else in the water, and that the water is still. We don't worry about that right now, but the idea is that we can use an equation to solve the problem. And I'm not going to go through the full solution here, folks. I'm just telling you how to do this. Again, you're finding the distance of this line, so from 0, 0 to 5,000, 7,500, so this coordinates here. We find the length in, using the distance formula, we find the length in centimeters, and we're going to divide it by the speed to find out how long it will take for the ripple to reach her. And like I said, it's about 180 some odd seconds. Alright, that's the end of the video, folks. I just wanted to go over one more question with circles. Hope this helps. Good luck on your test. Take care.